Okay, what we're going to do here is try to show you how to estimate the inverse trig function values for each of the major ones: inverse sine, inverse cosine, inverse tangent. You can see that I'm going to start here with inverse sine. Now, in order to do this, we're going to have to use the unit circle. Just a reminder of how the unit circle usually works for plain old sine. For plain old sine, we have a unit circle. Doesn't have to be great drawn, right? And what do we normally do is we plug in a distance and the answer is a y-coordinate. For inverse sine, we're plugging in a y-coordinate and the answer is going to be a distance around the unit circle. So we're going to start drawing some of the same lines we drew before. I know what y equals 0.7 looks like, right? Well, that's about y equals 0.5, that's about 0.75. So y equals 0.7 looks sort of like that. And so before we were trying to get both of those values, but arcsine is a function, which means when I plug in one number, I'm only allowed one answer. Now, how am I supposed to figure out which answer is the right one? The distance to this point or the distance to this point? Well, we use what we did when we erased. When we erased almost all the pieces of the inverse sine graph, what we did is we left the piece that was closest to the origin. In other words, we left the shortest distance. So for arcsine, the answer is always going to be about the shortest distance, like that. Now, how far does that look like? Well, in this case, I know that to get up to the top, it's about 1.6. This looks like about half of that. So I'm going to say about 0.8, and we'll be all done. So that's all you have to do to estimate an inverse sine value. Let's do an inverse cosine value. Estimate inverse cosine of something. Inverse cosine of how about something like 0.2? Now, in order to estimate inverse cosine, we have to remember what we did with unit circle for cosine. So again, I'm just going to come over here, draw a real simple unit circle. It doesn't have to be great. And remind ourselves that for cosine, we had to plug in we plugged in a distance and the answer was an x value. For inverse cosine, we're plugging in an x value and the answer is a distance. Now, x equals 0.2 is a vertical line. There's about 0.5, there's about a quarter, so it's going to be just a little bit to the left of that. So I know I need to know the distance there or the distance there. What we just discussed is we want the shortest possible distance, but the distance to this point is exactly the same as the distance to this point. Now, when you did your erasing of inverse cosine, you should have seen that you actually wound up erasing all the negative distances. So with inverse cosine, since both distances are the same distance, you always pick the positive distance. So we're always going to go up like this. I know up to the top is a 1.6. This seems to back up about 0.2. So we're going to say the distance here is about 1.4, which is about right. And you can see all that stuff we were estimating early on really comes into play here. And it really comes into play when we're estimating an inverse tangent. So we're going to estimate now an inverse tangent value. Inverse tangent of something. Now what do I want to do here? Inverse tangent of how about something like 10? Again, we have to go to the unit circle just to remember what we do with a tangent and the unit circle. With tangent, we plug in a distance and the answer is a slope. With inverse tangent, we have to put in a slope and the answer is going to be a distance. So now we have to be good, reasonably good, doesn't have to be great, at drawing a line through the origin whose slope is 10. Let me make this just a different color so it shows just a little bit. Real steep. Real steep. A slope of 10 is really steep. And we can see that there are 2 points on the unit circle where the tangent is going to be 10. And which one do I pick? We pick the smallest value. So the shortest value here is going to be like about 1.5. This is just a little bit further. It's like minus 1.7, but it's further. So what we're going to do is we're going to just estimate that. I said 1.6. I'm thinking about 1.5. All I did, by the way, was just go over and then come back. That's it. All right, so we estimated an inverse sine, an inverse cosine, and an inverse tangent. I'm going to do one more. because in trig these show up all the time, and I mean all the time. In algebra they don't show up enough. In inverse, in trigonometric functions, it's nuts. Okay, here we go. I'm going to estimate the inverse sine of 10. Well, again, I'm just going to go over to the unit circle. Go like this. How does sine work? With sine, you plug in a distance, the answer is a y value. With inverse sine, you plug in a y value, and the answer is a distance around the unit circle. Now, the way we did this before when we were doing unit circles, what we did is we drew y equals 10. Well, y equals 10 is way up here. And remember, what this is asking is, what distance do we have to go around the unit circle until we hit the line? Yes, that never happens. That never happens. What that means is that inverse sine of 10 is undefined. And that's the way we like to say it. Because we weren't trying to solve an equation. So we're not going to say no solutions. We're going to say that this function value is undefined. And because this happens so much in trig, you just get used to it. These are not trick questions. This happens most of the time. That's our ending of estimating inverse trig function values.